See, to ensure that whether we are making an elimination, substitution, and that too via SN1, SN2 kind, we need to realize what kind of bases that are required, which has to, I mean, which requires some heat or which does not require some heat. Please check it out. The first case, these are the bases which are very strong and they do not require heating and they will always favor E2 mechanism. Okay, so you can see these are all going to favor E2 mechanism here. Which are all those cases? R minus, H minus, RNH minus, R2N minus, H minus, NH2 minus, tert, tert alkyl amine, tertiary alkyl amine, tert butoxide if it is given alcoholic KOH. Well, in alcoholic KOH, in certain cases, heat will be always mentioned in the exam. But even if it is not mentioned, most of the time you will always go for heating, sorry, elimination only. So for example, if you have this base, these bases, and you have it at primary position, okay, then you will get this as an alkene plus X minus, and that will give you E2. All right. Then, so if it is in a secondary position here, you will get this as an alkene and X minus. This is also via E2. This one is also via E2. This one is via E2 mechanism. Hmm. So now you will get this as E2 mechanism in all the cases. But if your rate is R1, R2, and R3, you will notice that R3 it will be stronger rate because of the stable alkene. So the stable alkene will always make it for a better rate of E2. Next, don't worry about mechanism. We have discussed it already. Check out bases which are very strong and need some heating to it, like RO minus and heat, RC triple bond minus and heat, phenoxide and heat, ammonia and heat, secondary amine and heat, primary amine and heat, acetate and heat, cyanide and heat, carbonate and heat. If these kind of cases are given, elimination will happen, right? As long as the heat is given. Like in the case of primary position, if heat is not given, definitely you can go for SN2. But if heat is given, you go for major product as E2. Secondary position, if heat is given, you definitely go for E2. Tertiary position, with or without heat, go for E2. No SN2 will happen, so it will only go for E2 mechanism. Okay, so this idea you should have in which cases what kind of group you should go for. Okay, now let us start with this case. Suppose I have a methyl chloride. Okay, and then I'm treating with these reagents. You can see this is a weak nucleophile. This is a weak nucleophile, very weak nucleophile, strong nucleophile, moderate nucleophile, and extremely strong nucleophile. In all of these cases also, if you are pushing that on methyl chloride, there is only one mechanism that will happen, and that is SN2. Okay, clear? Only one exception you have for SN1. That SN1 mechanism is like this. CH3 only if the leaving group is N2 plus diazonium salt. In that case, first a carbocation is formed, even though methyl carbocation is highly unstable, that is formed. And then, because this happens usually in water, water will attack as a nucleophile and you'll get methanol. So only this reaction happens via SN1. Okay, but otherwise, if the leaving group is any other group than N2 plus, generally they all go for SN2 mechanism. Next, you can see that here, if you have an ethyl chloride, in this case, you can see with water, you will get this as SN2 mechanism. Okay, OH minus SN2, OH minus, and heat also SN2, alcoholic KOH. Now listen up carefully here. Whenever an aqueous solution is given, right? In aqueous solution, eliminating the molecule is extremely difficult. Even if it is in a primary position, secondary position, or tertiary position, even when you heat it, generally it will go for substitution only. अगर मिथाइल एंड 1 डिग्री है तो SN2, secondary and tertiary है तो SN1. Okay. If you have RO minus, it is SN2. If it is RO minus, correct, with heat, it is E2. Tert butoxide, because it does not require any heat, it is E2. Ammonia is SN2. With heat, it is E2. H minus, no heat is required, it will only give E2. NH2 minus only give E2. Okay. So please check these cases quickly. Ethyl chloride, in which case what you need to perform. Finished? Now notice secondary case. In case if you have a secondary chloropropane, check out. If you have alcohol, water, that is, it does not have any charge on the nucleophile, then definitely SN1 and SN1. The minute you have some charge on it, RCO minus, it is SN2, OH minus, SN2, OH minus in water also SN2, RO minus SN2, right? These are all SN2 kind. Now notice this. Ammonia, of course, neutral charge, so SN2. But you have a strong nucleophiles like CH3 minus, ammonia and heat, tert butoxide, H minus, alcoholic KOH, RO minus and heat, okay, and NH2 minus. All of these will give you E2 mechanism. All of them will give you E2 mechanism. Cyanide and heat also, okay. But if you have given only cyanide, no heat, okay, or you have given I minus, these will still give you SN2, okay. So these are the cases you have to keep on repeating yourself. Write this kind of, a tree diagram and try to always try to check whether you are able to get the right product or not. Last one, tertiary. In case of tertiary, you can see if it is alcoholic, if it is simple alcohol, SN1, water, SN1, OH minus SN1, OH minus aqueous SN1 with heat or without heat, always SN1. RO minus E2. Now see, RO minus is actually supposed to utilize heat, correct? But even without heat also, if RO minus is mentioned on a tertiary position, you will go for elimination more than anything. NH2 minus, heat or no heat, E2. RO minus and heat, definitely E2. CN minus also E2. H minus is definitely E2. Alcoholic KOH is definitely E2. Tert butoxide is definitely E2. Cyanide and heat is definitely E2. Ammonia and heat is definitely E2. Even only ammonia given heat. So no heat is required now. CH3 minus is definitely E2. RCO minus is E2 or SN1. It can give both, right? Just the heat differs. Slightly heating, E2 will favor. No heating, SN1 will favor. Okay. So these are the cases you need to learn. Please check. Okay. Correct. Now notice here, this I have made it little wrong. When you have tertiary position with OH minus or aqueous solution, you will have a competition of SN1 and E1 also. Okay. E1 would come, correct? But major or minor is very difficult to say. But if it is only water given and heat is given, correct? Like concentrated H2SO4, like this. Sorry, not water. I meant to say acid. If this is how it is given, concentrated H2SO4, H plus. Okay. But not X here. It should be alcohol. If it is alcohol with heat, then it will go for E1. So let me specify those reactions here. For example, if you have an tertiary alcohol and you are reacting that with concentrated H plus. Now this concentrated H plus can come from concentrated H2SO4, concentrated H3PO4, anything it can come from, correct? This will always give you alkene as long as heating is concerned, okay? Even if the heat is not given, generally it favors alkene. Concentrated H plus and heat is given, definitely the same thing. The mechanism is via SN1. Here also it is SN1. If this is being treated with Al2O3 and heat also, same product and it is going to be SN1. Here, if Al2O3 is provided in the presence of pyridine with pyridine and heat, then also you will get it as alkene, but this time via SN2 with Shedzef as major product. When there is a difference, you need to select. Okay, and if you have SOCl2 and heat, POCl3 and heat, any one of that, again you will get the same product here, right? Which is Shedzef, and this one alkene. And lastly, if you have thorium dioxide and heat, you will get the same product, but this time it will be Hoffman. If there is a possibility of Hoffman, then it is Hoffman. Okay. So this is with alcohols. Okay. Typically with all alcohols, this is what you will notice. Sorry. Yeah, I keep writing suddenly it slips through my mind. Sorry. I'm talking all about eliminations. E2, E2, E2. So these are all going to be E1 kind. These are all going to be E2 kind. Okay. Clear? So noticing this, now let's get back to the questions. Got it? Okay. There are a lot of good questions in this sheet. So if you are able to do most of them, I think you'll be well off with all the type of reaction mechanism cases. Check out. Basicity. If you go from left to right, what happens to the basicity? Okay, whether it is increasing or decreasing. Okay. I'm taking one or two cases. Rest simple ones I'll be leaving it here. Okay. So check out. First, you know that this is coming from alkane, this is from alkyne, ammonia, and water. Out of all these, water is the most acidic one, so that will be the least basic. So answer is A. Okay. Next, left to right. Left to right, you know that acidic strength increases, so the basic strength decreases. So the most basic will be B. Got it? Sorry. Here we are talking about pKb values, which means we are talking about least basic. So that is A. Okay. And these are the ones which I'm leaving right now. Okay. Come to these two questions. Eighth and ninth. Among these nucleophiles, which of these are the order in DMF? DMF is an aprotic solvent. In aprotic solvent, iodine will be the strongest nucleophile. So therefore, B. If it is in water, correct? Sorry, in aprotic solvent, fluorine. Fluorine will be the strongest nucleophile. And if it is in water, then iodine will be the strongest nucleophile. Okay? Because in water, which is a polar protic solvent, fluoride will be surrounded by a lot of water molecules. Okay? Clear? If it is in polar protic solvent, so bromine is greater than chlorine, iodine is greater than chlorine and bromine. Okay, here. Next, check out 13th. Which reacts most easily with ethanol? Okay, so basically you have some bromine group here, benzyl bromide, and there is some group G here. That G is nitrobenzene. So G is NO2, G is chlorine, G is methoxy, G is only methyl. So if we compare these two, definitely because ethanol is a weak nucleophile, so this reaction is most favorable via SN1. So for SN1, stable carbocation is what you would look at it. So O-methyl, OMe, methyl, chloride, and NO2. This should be the order. So best one is C. Okay. Isopropyl chloride undergoes hydrolysis like this. Hydrolysis can happen only with water, or hydrolysis can happen with OH minus and water. So that means in acidic medium or a basic medium or neutral medium, hydrolysis can happen. In such case, you can get OH. Now, only water is used, it will majorly go for SN1. With OH minus is used, it will go for SN2. That means both are possible. SN1 and SN2 are possible. Okay, next. Which one is most reactive towards nucleophilic substitution? So listen. Lone pair present on oxygen is always in conjugation here. Here also it is in conjugation. And in phenyl also it is in conjugation like this. Since it is in conjugation, it is very difficult to break this carbon chloride bonds. So they do not make any nucleophilic substitution. Only D will make because it is allyl. Allyl will make best SN1 as well as good SN2. Next, which of the following is an example of SN2 reaction? Okay, definitely OH minus attacking here, Br minus leaving. This is an SN2 reaction. Okay, now when you have OH minus attacking here, Br minus, this is also SN2 reaction. Correct? Correct. This is also an SN2 reaction. This is an elimination reaction, right? Here, OH minus attacking on this position, removing Br is very difficult because OH minus is a strong nucleophile. So it will favor elimination over substitution. So this is not going to be impressive. This is not going to happen. Now, this could happen, but in a smaller amount, correct? Because we don't know how much amount of that will be made. So therefore, the best reaction is A. Okay. Right. Next. Check out in SN1 reaction, the racemization takes place. It is due to. Okay. Racemization is because of the inversion as well as retention product. So that is B and C. Next. SN1 reactivity only on the basis of stable carbocations. So you can see here it is 1 degree and here it is 2 degree allyl. Here it is only 2 degree. So definitely 2 degree allyl will make more stable carbocation. So 2, 3, 1. Correct. So that is this one. 19th one, more stable carbocation. Here it is allylic. Here it is aromatic. You can see this will be an aromatic ring. Here it is anti-aromatic. Here there is no resonance. So true is definitely better. Okay. 2 is definitely better. And as compared to that of 1 and then 4 and last the worst one is 3. So 2, 1, 4, 3. Okay. This is the one. 20th. What about SN1? Okay. Stable carbocation. Now notice this one. This is very interesting one. On benzene, when you have CH3, right? You need to check out number of alpha hydrogens only. That gives most stability. Here it is 3. Here we have 2. And here we have 1. Here we have none. Okay. So the most number of alpha hydrogens will give you most stable carbocation. So 2, 3, 4, 1. Okay. So 2, 3, 4, 1, which is A. Clear? Next. 22 also now you can do rate of carbocation. 23. Check out 23. This is interesting one. Check out. You get a carbocation here. Both side you have benzene ring stability. This side you have only one side benzene ring stability. Okay. This side you have benzene ring stability, but it is still withdrawing, so it will be highly unstable. This side you have stability of one benzene ring, but two benzene rings not at a time. Okay, so that means it's relatively A is better, then D, then B, then C. Okay. So the most impressive SN1 reaction in this case is A. Any doubt so far? Now notice SN2 cases one by one. Okay. So first, I would give you some time for these cases 26, 27, 28. Try them out. Got it? And then I'll discuss one by one. 26th one, we can see that this will be the most favorable SN2 here. So because this has the least crowding, after that it is Q, then R, then S. Should be the case here, P, Q, R, S. Next one, the least crowding is R. Thereafter, the next least crowding is Q, then P, then S. So what should be the case here? R, Q, P, S. Okay. Next, 28th one. You can see this one has the least crowding. Then the next least crowding is here. After that, the next least crowding is here. And the most crowding is here. Because you need to always check out direct uh, direct connection on this position. How many groups we have. Here we have two bigger groups. That means this will have the lesser amount of SN2 substitution. So what should that be? PRSQ. PRSQ. Okay, clear? 29, if you notice, the order is very important. You need to keep revising the SN2 order, everybody. Let me remind this once again. If these kind of group is present, that will be the most stable. I mean, that will be the highest recommended SN2. Then you have any lone pair carrying group adjacent to the halogen, then that is going to be the most favorable for SN2. Then comes benzyl position X, then comes CH3X, then comes allyl X here, then comes 1 degree X, then comes 2 degree X, then comes 3 degree X. Okay, this is the order you must remember. Got it? So you can see the worst part is vinyl, definitely. That is not going to impress it at all. So first one is R, then Q, then P, then S. R, Q, P, S. So that is D. Okay. Make sure that you are aware of the SN2 mechanism. All right. Next. Now, take these three cases and do SN1 beta 31, 32, 33. Quickly try this out. So please check this out. If you want to check out the order of SN1 here, you need to check out most stable carbocation. That includes S, and then we have uh, between these two, if you notice that the most stable carbocation, you will get a plus charge here. Removing this, you'll get a plus charge here. Hyperconjugation wise, it looks like Q is more than R here, isn't it? Q looks to be more than R. So that will be Q, then R, then S. Okay. Next 32. Resonance. This is a simple allyl. This is an allyl at a secondary position. Allyl at secondary position. And this is vinyl. Vinyl is highly unstable form. Okay. So allyl at secondary position, this will be the most impressive one. So Q, then R, then P, then S. Okay. So QRPS. QRPS. Next. Here, we just discussed it already. Okay. So the most favorable one in this case will be which has more number of alpha hydrogens. So PQRS. So it should be PQRS. PQRS. Okay. Rest I'm sure you can do that. Clear? Now, let's do few simple elimination ones. Check out. The major product formed in the following 38. Check out on 38. Okay. This is at a primary position, but heat is given. So definitely we'll go for E2 mechanism. So through E2 mechanism, this will take H plus, Br will go, and you will get a double bond form here. Okay. This is the product you will get. So what is the product you should be aiming for? C. Next. The major product obtained while treatment of this one. See, check out. In the case of 37, you have fluorine here and then you are reacting that with MEO minus. You know that fluoride will make an Hoffman case because it's a weak leaving group. So methoxide will take H plus from here and you will get a double bond here. So what is the product? Major product is C. Okay. Next, N-propyl bromide on treatment with ethanolic potassium hydroxide. So, N-propyl bromide on treatment with ethanolic potassium hydroxide. So I told you that whenever you have an alcoholic KOH, always go for elimination more than substitution. So propene. Okay. Now notice this case, everybody. When you have an 3-degree amine group here like this, then you see this is alpha, this is beta position, beta position, beta position. Okay. On elimination, OH minus has the chance to take H plus from this position. It can have chance to take H plus from this position. Then the major product depends upon which one will get more delta negative charge, because Nr3 plus does not leave that easily. Whichever has more delta negative charge, that is the direction where the elimination happens more easily. So which means this direction is better and this direction is not that good. Okay, so Hoffman product is more favorable, which is A. Please check. If anyone has any doubt in these cases, they can ask me now. Please check. 38, 39, 40, 41. Samyak, all good? Anish,
Yes.
Rabia, Sudiksha, Pratisha, you there,
Yes,
beta?
yes, sir.
Right. Check the same logic in 42 also. First, Hoffman exhaustive methylation. So first we will get methyl and methyl here plus charge here. And then OH minus can eliminate from here the bond will go away. The base will take H plus from here. So this is how the elimination will happen. Double bond here with N and 2 methyl. And further methylation will give you this way group. And from here, bond will break. Hydrogen from here will go away. Double bond will come. So B will be the product. Okay. Next. Check out 45 now. I told you primary amine, ammonia, secondary amine, if it is given, you will always think of E2 as soon as the heat is given. And most importantly, the position is tertiary, so definitely E2. So Br will go from here, H can go from here or H can go from here. Br is a good leaving group, so Shezef is more favorable. So which one will be the formation? Double bond, like this. But imagine if the same question is given as R3N. In that case, because it is a bulky base, in that case, the major product will be Hoffman. Okay. 46. Okay. In the case of 46, what we need to check here is uh, fastest elimination will be on the basis of which is anti-elimination. So here Br is coming out of the plane and hydrogen is inside the plane. So definitely this can go for an elimination on this position and you'll get this as a product. Here you will not get this product because this side uh, hydrogen is on also on the same side. So elimination happens on the other end like this. This is the product. And here also elimination could happen on any side. And here also elimination could happen on any side here like this. Okay. In that case, the most stable product is A. So A will be most easily coming out. Okay. Right. So based on that, I would suggest you to try 47, 48, 49 once quickly. Try it out. Take the first case. We have a third butoxide here. Definitely go for elimination and that to Hoffman kind. So B. Next. Here Br is here. So E2 is not possible for only one reason, because hydrogen is also on the same side. Actually, this is like this. So hydrogen is also on the same side here. Hydrogen is also on the same side here. So E2 is not possible. Since E2 is not possible, it will go via E1 mechanism. Okay. Okay. So in that case, you would have like this, and then first carbocation will form, and then the carbocation. Okay. So once you get this here, and thereafter the elimination will happen. So which one will be the product? This one. Okay. Actually, this was an old JE question where it was given no reaction, considering it was no E2 reaction. So if the question was specifically mentioned that there is what is a product via E2, that means answer is no reaction. But if it is only given product, it can definitely take a case of E1 and you can get this product. Okay, next. Check out here. Now, alcoholic KOH, we need to perform what is a product. You know that alcoholic KOH is an anti-elimination. And see how hydrogen and bromine are aligned. These two are on the same side, which makes it erythrokind. So, if there is erythrokind here, okay. Hmm. So if there is erythrokind, you can see erythro anti should give you trans. Okay, so trans means these two should be opposite, these two should be opposite. So how would that product be? B. Okay, B is that product. Clear? So I hope all of you got these points 47, 48, 49, how they are. Okay, next. These are similar ones. I'm just skipping a bit here. And mm, yeah, come to 54 now. Please check 54. The major product obtained when the alkyl halide is subject to E2 mechanism. Okay, so you can see for E2 mechanism, you should think in a regular case. So Br is going. The volume. The volume. So Br is gone. So H plus can be removed from here. H plus can be removed from here. Getting a double bond here will make it more stable. So which one is that case here? Okay. Uh, this one, the A case. The first one is the major product. Rest all will be formed, but they will be in the minor product. Now, what if I use the same question to ask you what are the maximum number of alkenes that we can get? So, one, you can see how I can write down. So, this is 1, 2, 3, 4 here, and then we have 5 group like this. This is one product I can get. Okay, and here we have two methyl groups. Correct. Second product is like this. We have two methyl group, and next carbon we have methyl. You can make a double bond here itself. Next one, if you notice like this, double bond can form here like this is the other product which you can get. So these are the three structurally possible compounds. Here there is no cis and trans, here there is no cis and trans, but here there is cis and trans. So you will count this as 2, 1 and 1. So the possible products are 4. Okay, so like that, if you were asked about elimination product in this case with alcoholic KOH or something, you can use this. Okay, next. 56, what is the major product that is being asked via E1 mechanism? So check it out. If it is via E1 mechanism, so this will be like this. Methyl will be here with carbocation. It is already at a more stable position, so we can directly make it into an elimination here. So B. B is the major product. Okay. Same question if you have it with E2 mechanism, right? For E2 mechanism, because we have to make a simultaneous attack and removal here also, if Br is coming out, so definitely H is inside, so that makes it easier for making a product. So now this is via E2 mechanism. Okay, so A. Once. Check out 63. Which of the following alkyl halides will give you alkene as a only product in elimination? This is the only product that you should get in elimination. Okay. Now notice if I take first case, you will get beta here and beta here. So double bond can come here, double bond can come here. If I take this chlorine, I can only get double bond here. So the product is B. Okay. Right. Now I want you to do this first three, SN versus E, substitution versus elimination. Everybody, 64 to 66. Try it out. Equation 41. SN1 competes with E1. True. The only thing that changes differential part between them is temperature. SN2 competes with E2. That is also true to some extent, but here the competition is more to do with the nucleophilic strength. Okay. SN2 will always offer, SN1, sorry, SN2 and E2 will be happening with strong nucleophile or strong base. Okay. So this will compete on a different level. This will compete on a different level. Okay. So see, both SN1 and E1 have same rate determining step. Therefore, E1 competes with SN. That is absolutely true. There is no problem with that. A base is a nucleophile. Nucleophile is a base. That's why SN2 is competing with E2. That is also true. Okay. So therefore, both these statements are true, everybody. Next. This is a DMF and it is, this is the alkoxy group at a primary position, highly favorable for SN2 mechanism because everything which we expect from SN2 is matching there. Next. The minute we use tert butoxide, I told you, we will only think of elimination, that to E2 kind. Okay, so this will take H plus from here, convert into an E2 form. Next, cyclohexyl bromide here with CH3O minus. Now this CH3O minus, if you notice that it can take H plus from here, remove this bromine here, we can get double bond. And at the same time, it can attack here, remove bromine, make an SN2 mechanism. So these two would be the cases which you can get. But predominantly what it gives you, correct, if it is been asked, then I would still go for E2. Okay. Right. But here temperature is not given. So both of them will be impressive. SN1, SN2 and E2 both will be impressive enough. Okay. That's why D option is more favorable. Sorry. Next note is 69. The minute I have tert butoxide, what I should think of, everybody? Only E2. Okay. Now you notice this case. You have a 3-degree amine. Water is given. Water is a very weak nucleophile as well as base. So then SN1 and competes with E1. Right. So A. And how do we get whether it is more, which one will be major depends upon heat. So if you're strongly heating, you might end up getting alkene. If you are not heating, you will end up getting SN1. Okay. Okay. Then, if you have water and heat, definitely you'll think about E2 mechanism, E1 mechanism, sorry. So you will have positive charge here first, then methyl shift here, positive charge will come here, and thereafter you do the elimination part, so double bond. So you will get D as the product here. So mechanism is E1 type. Okay, right. Now come to these cases quickly. From where the important question starts, I'll tell you. Yeah, starting with 13. Okay. Now this will have all multiple correct comprehension every type. So check out 13th one. These two compounds are given. What are those two? And what is the reactivity which will happen? Check out. If you notice here and here, correct, the number of carbons are same, 1, 2, 3, 4. Chlorine is same. So definitely these are isomers. But position of the chlorine is different. So definitely they are not stereoisomers. They are constitutional isomers. So B is correct. Next, SN1, this 1 does not go for either SN1 nor SN2 because it is at vinylic position. So reactivity of 1 will be least in both the cases. So whether it is SN2, whether it is SN1. So answer is BCD. Please check. Check out 15th one. Which of the bases would give best yield for substitution when reacted with 2-chloropropane? So 2-chloropropane is there. I need to check out which can give more substitution, which is SN2 kind. Now, in such cases, my suggestion is check out their strong basic character. Stronger the base, less is the probability for SN2 because they will always go for E2 more. So, if you notice the basic character of these cases, basic character wise, you know that NH2 is extremely strong, then ethoxide, then OH minus, then acetate. So, at acetate being the weakest base, it will always go for more substitution. So, OAC will come here. Okay. So this is the product. Next, which one will go best for SN1? Simply carbocation stability. So you can see the most stable carbocation is this one, aromatic, OCC, octet completed carbocation. So that is the most stable one. Okay. Now check out the 17th one. Which of the following phrases are correctly linked with SN1 reaction? Okay. So you see, rate is affected by polarity of the solvent. Very true. Correct, because polarity is more, right? If the polarity is more, rate of SN1 will be more, SN2 will be less. Rearrangement is possible, true. Strength of nucleophile is important in rate determining step, not true, because in SN1 rate determining step only depends upon uh, reactant concentration and not with the nucleophile. Next, reactivity series will be tertiary, secondary, primary. That is how it should be. Clear? Any doubt, please let me know. Next. See, rate of reaction is dependent only on the concentration of the nucleophile in SN1 reactions. Okay. Concentration of not the nucleophile but the substrate. So this is false. Polar solvent favors SN1. That is true. So this is true here. Got it? So in the case of assertion reason, you need to check out these options first. Let me show you the options like this. Okay. If both are correct and correct explanation, that is A. If both are true but not the correct explanation, B. Assertion is true, reason is false. Assertion is true, but assertion is true, reason is false. If reason is true, assertion is false. Okay. These are the four options which you have. So notice here, the first one is false, second one is true. So that means it is D. Okay. Next. SN2 reaction of this one is faster in DMSO than H2O. That is true. DMSO has a greater capability of solvating nucleophile. False. Solvate will be, for example, F minus is a nucleophile, CH3, some leaving group is here. It has to go and attack. If it is in a polar solvent, polar protic solvent, water molecules will surround it. This is called solvation. So it becomes very difficult for fluoride to go all the way. But if it is in DMSO, this solvation will not be there. So F minus will run very fast. So this one is false. So answer is C. SN1 mechanism, the product with the inversion of the configuration is higher amount compared to that of product with retention. This I told you that when it comes to SN1, due to intimate ion pair effect or tight ion pair effect, intimate ion pair effect. Okay. So intimate ion pair, due to intimate ion pair effect, the inversion will be slightly higher than that of retention. Hmm. So this is a true statement. Front side attack of nucleophile is hindered due to the presence of leaving group in the vicinity. Okay, that is true. This is a true thing, and there is a correct explanation also. Okay, so this is not a true explanation. Sorry, this is a true explanation as well. Okay, okay, right. Next, check out 22. See the next one. Which of the following statement is correct about retention or inversion of the configuration during the course of reaction? Configuration is retained if the reactant attacks from the same side of the leaving group. That is true. Configuration is inverted if it is attacked from the backward. That is true. No change in configuration if the bonds of asymmetric carbon are cleaved during the course of EM. Now listen, try to understand what is that C point is. For example, I have a methyl here, deuterium here, hydrogen here, and then there is a chlorine here. And then let's say there is an SN2 mechanism using OH minus, and I got a product as like this: OH here, deuterium here, methyl here, and H here. Now notice we are not breaking any of these four bonds, isn't it? We are breaking carbon and chlorine bond here. That's it. Therefore, as long as this asymmetric carbon bonds are not broken, its configuration is not changed. It will still remain the same. So which means configuration which might be R or S, that will remain the same. So which means all of these are correct here. Okay. Let's see the 23rd one. This one will react more than this one in SN2 because that is true, as the lone pair will support carbocation will be more stable compared to the second one. So A is correct. This one is more reactive. This is untrue because the carbocation on the bridge position is highly unstable. So this is wrong. Next. This one is more reactive than this one. This is true because removing chlorine from here creates a positive charge and ring will become aromatic. Okay. Here chlorine is already is in resonance with it, so it is very difficult to remove chlorine. So no reaction. Okay, so this one is also true. SN1 reaction happens better in polar protic solvent. Okay, next. Which of the following are SN2 reactions? So first one is SN2. Second one is not because it is a tertiary position. Third one is SN2 because it is an aqueous solution. Fourth one is not because it is alcoholic solution. It is going for E2. E2, SN2. This is E2, and this is SN2. Okay. So please check the reactions. All good. 25th. Please check out 25th. Which one is correct? Which of the following will not give SN2? Bridge position will not give, vinylic will not give, phenolic will not give, tertiary will not give. All of them will not give SN2. Which will give SN1? Okay. OCC will give you, tertiary will give you. So C and D. Okay. Hmm. Now, these are some good questions again. 27, 28. Please check. Which of the following compounds will give SN1 reaction? Okay. Tertiary, this tertiary position will give you. Okay. And that's it. That is the one which you can see the best SN1 reaction. Which will give racemized product more in ethanol. Now, it is a good one. So if you want more racemic product here, then what you need to check? If you want more racemic product, you need to check which has more stable carbocation nature. So out of these four, which one has more stable carbocation nature? So see, this is at secondary position, this is at tertiary position, this is at secondary position, this is at tertiary position. Out of this, which one is more stable carbocation? B. So more the stable carbocation, more is the chances that the attack from top and from the bottom will happen, right? So that gives you racemic mixture. 29. Which of the following will give SN2 reaction? Okay. Benzyl will give you, that's it. Rest all will not give SN2 reaction. Okay. How many of these will show rearrangement? Okay. This I will give you for a minute's time. Please try it out, everybody. Then I'll discuss. You need to check how many are going to give rearrangement to get SN1 reaction. The rate of ethanolysis of 1 degree halogen by SN1. See, if I remove the bromine, I'll get positive charge here, which can be resonance stabilized. Okay. So SN1 will happen faster, which is true here. Carbocation is stabilized by resonance. That is also true here. So both of them are true. Correct. So A is correct here. Okay. Treatment of 2-chlorobutane with aqueous NaCN like this. So we have butane and 2-chloro here. Let's say this is +1. And that when you react with Cn minus, you will know that it will go towards levo kind. That is minus. Correct. So you can see treatment of this with aqueous NaCl gives levorotatory product, which is true. SN2 reaction leads to inversion of configuration of alpha. That is true. So again, the reason is also correct. So which is A. Okay. Here everybody. So check. Now please check this out. 38. Everybody. It's a good question. I want you to try this first. Please check out. The reactant is giving an A2 mechanism to get this as some kind of an transposition here. Okay, correct. There are multiple ways of doing it. First, what I would suggest you go with the regular mindset of, doing with the simple tricks. So if this is trans and it is making an anti-elimination, correct? So it must be from an erythroform. Must be from an erythroform. Okay. So you notice that if it is from an erythro, that means the leaving group, that is chlorine and hydrogen, should be on the same side. Okay. And you can see, uh, if let's say that is the case, then because it has to be like an anti-position, this phenyl here and CH2 pH here, correct? And CH3 here, right? Correct. And sorry, H here and CH3 here, like this it should have been. Because now you do the reverse one. This is an erythroform of H and Cl. Remove it off by anti-elimination. Then this group and this group should become trans to each other. Right? So if those two are trans, then these two will be automatically trans to each other. Okay. So I think this is correct. So now check it out. Which of those cases are possible? Now you might ask, sir, why chlorine only there? Why not at the bottom side? Yes, that is also possible. Okay. In fact, if you have methyl here and chlorine here, hydrogen here, correct? Sorry, methyl up here. I mean, methyl is still here only. Okay. Chlorine is here and CH2 pH is here and pH here. Still, you will get the same type of elimination. So, this is also correct reactant. This is also a correct reactant. So, check out which one is that case here. So, first one, okay, H and Cl here, methyl and H here. So, this is matching. The first one is matching everyone. Second one, you can see chlorine hydrogen and methyl hydrogen here. So that is also matching, correct? So B is also the one which you can get. Okay. Next, C, chlorine hydrogen here and methyl and hydrogen here. Okay. That is the same as this one, just the you know isomeric form of it. That's it. Okay. This one is not matching because chlorine and hydrogen are on the opposite side here, which means while performing anti-elimination, you will get cis as a product. Okay. So A, B, C, all of them will give this product. Anybody has a doubt? None? Right. 40th. Check out 40th, everyone. Please try it out. Debromination of meso-dibromobutane will give you. Mesoform here is like this. Mesoform is Br, Br, H, H, methyl, methyl. Now this, if you're doing debromination, then debromination is an anti-elimination. Okay. So since it is an anti-elimination and this is erythro anti, so we should get trans. So this is methyl, methyl here, H and H here. So this is the product what you should get. Okay, this is the product you should be able to get. Yeah, I'm not sure if you do recall the uh, debromination which we discussed during the elimination reactions in alkenes. Let me remind you. Suppose if you have, you know, in case if you have any halo, sorry, if you have any, if you have any vicinal dihalides like this, and you treat this with NaI, okay, in acetone, NaI in acetone. So what would happen here is this I minus will take bromine from here instead of hydrogen, pushes this bond and remove this bromine. So now you can see it is a proper E2 mechanism with anti-elimination. So here we'll get a double bond plus IBr plus Br minus. Okay, Br minus basically is becoming NaBr precipitate. So here NaBr precipitate is observed. Okay. Second thing, in case if you have two bromides or two halogens here, if you simply use zinc and heat also, the electrons from the zinc will attack here, get a negative charge on it like this with Zn Br plus, and then that negative charge will be pushed here, Br minus will go out, and you will get a double bond, and this will become ZnBr2. Again, it is an anti-elimination which is favored like an E2 mechanism. So these two are the main mechanisms or reactions through which you can get dehalogenation. Clear, everyone? Right. Everybody do 42 and 43. Please try 42 and 43. Here, like this, 42 and 43. Pr has been removed from here. I'm breaking hydrogen bond or breaking deuterium bond here. Hydrogen bond is more easier to remove. So what do I get? 1, 2, 3, 4, 5. This is CD3. Here we have hydrogen, which gets a double bond. And then we have two deuteriums here. So this is the major product that you need to look into. Okay, clear? So CBr with CH double bond. Okay, this is CD3. So which one is that? A. A is your major product. Which of the following reaction of the following compound with alcoholic potassium hydroxide? Okay. Now you can see Br is here, so H will also be on the same side. So what do? We'll keep it like this. and make the elimination on the other side. So Hoffman is more favorable. This is a product you will get. Only one product. This is the one. Okay. You will not get two products here. Correct. Because Br removal and H removal will be happening anti. You will get only one type of double bond here. So what do we get? One methyl cyclohexene only. This is the product. Okay. Done. 45. Through alcoholic QOH, what are the products that you can get? See, first one, Br removal, hydrogen is here, hydrogen is here. So definitely I will get product as double bond here and product as double bond here. Okay. If the number of products are asked, then this is a chiral center, this is a stereo center, this is a stereo center. So here you will have two, here you will have four. Total number of products are six, if that was a question. But here you see what are all the products you can get. This one you can get, this one you can get, okay, and this one you can get. D we can't get. Okay, next. Let's show this. 49. Anti-elimination is for E2. Must have acidic beta hydrogen, that is E1CB. No effect of solvent, that is EI mechanism. EI is that ester pyrolysis. Okay, reference ester pyrolysis. Okay. Lastly, carbocation formation is E1 mechanism. Okay, right. So guys, see,